Hi everyone, welcome to my live stream. Thank you so much for joining us today. Well, it's been a really busy period actually. I've got so many projects coming up, so many events. There's one in Milton Keynes this Friday actually. If you're in the Midlands, in the UK, come and check out. No, it's not Friday, it's Saturday. It's part of the City of Lights and Code festival at Milton Keynes Station. There'll be some bands and stuff. My crew are going to set up a laser show there. They'll be running it twice in the night, so come join us there. Then next week I'm helping my friend Flora, who's got a laser installation at Light Night Leeds, one of my favourite light festivals. I'm not exhibiting there this year, but I'm helping Flora out. She's a really cool new light artist. I'm helping her with some of my lasers and some of the software, but that's Light Night Leeds is always worth checking out. Alongside all of that, I've got a million other inquiries coming in at the moment. Yeah, so I really don't have time to do a live stream. I'm way too busy. Say hi in the comments if you are, if you can hear me okay. Yes, I think it's a new streaming setup, so I hope it's okay. Anyway, I just wanted to quickly update you on a project I talked about on the last video, which is the laser network switch. So just to recap, I like to use a system where I feed in the laser stop signal into the Cat5 cable using the spare wires inside a Cat5 cable. You know, a network cable. And now I've got a new design of stop button that has a reset switch, you know, because really if you want to conform to the British regulation, which is BS 60825, then you should really have a restart button separate from when you release the stop button. Anyway, so I put those signals down the spare 4 wires in a Cat5, and then I built a network switch which takes that signal in, splits it up into 7 outputs that I can then plug into the lasers or into other network switches. And I've had a few designs of those over the last few years, but I'm designing a brand new one, which hopefully will be a bit more robust because my old ones have been rewired so many times. I've built so many different systems and it's been a work in progress. And so finally, I just wanted to redesign it. So just a quick aside, I've got a question in the comments. How are your 3D printed PowerCon adapters holding up? I printed one, it got a lot of cracks after 1 gig. Okay, so this is a PowerCon socket that I designed, a 3D printed, put in a PowerCon socket into it, so it would be in line. I've had no trouble with mine at all, but I ended up not needing them anymore because, well, maybe I'll show you why in a moment. But yeah, they held up fine. But I did discover that you can buy those PowerCon sockets now, inline PowerCon sockets on thomann.de, so go and have a look there. If I remember, I'll add a link in the description. Anyway, right, this network switch. So you may remember in the last video I'd made a design in KiCad and I would almost finish it, but actually I did do some modifications and I sent it off and here it is. There you go, look at this. Oh, don't you love getting a PCB back from JLC PCB? Not sponsored, by the way. But yeah, I'm so happy with this. So one of the breakthroughs that I had was that, you know, I was trying to figure out how well, okay, let me rewind a little bit. This is the network switch that I wanted to interface into. And these are all my bits that sort of add the stop signal and the stop button. And I just wanted to plug that into there. So I found these little RJ45 PCB mount plugs, which are amazing. But I realized that if I actually, since I did the design in the last stream, I realized that if I turn this upside down, the wires are it's a little bit easier to wire up, but also there is this tiny little LED light here, and I wanted to still be able to see that, and I thought at one point I might do a light pipe, but anyway, if I had it that way it would be behind these Ethicons and I wouldn't be able to. So turn it upside down, easier to wire. I can still maybe see the lights, these squeezed together. I've got to make them completely flush. There you go. Ugh. And there we are. So that's cool. So in an older version of this board, I built a big PCB that this sat on. So this, I'm really happy with this though. I think this is a much slicker solution to the problem. So you notice there's a few little extra jumper wires that I've soldered directly into this. So that's to get the signal from the LEDs out and into this board. So I connected to this 6-pin JST cable. I wasn't sure if I would end up using this system or end up putting some light pipes there in the little holes that match up on the board, but in the end I think this is good. I'm using this cable and it's feeding the data signals into the LED. So just to recap, this is so that I can see that the switch is getting data, and that's a really important thing to have broken out of the switch into the front panel. So yeah, that's looking pretty good. So let's have a look at how I put this into an enclosure. And for that, I'm going to move you over here. Right, let's see. Oh, see the other side of my room. It's a bit messy. I generally don't show this side. How well are the two PCBs connected? Can't it fall out if the flight case gets knocked about? Yeah, possibly. I mean, it's quite a strong friction fit, but obviously with vibrations, it could come out. That's one of the things I want to test, but I have also put in a little standoff there so I can bolt it to the enclosure too. Anyway, let me switch to my overhead camera. It's my iPhone, so it's a new setup. See how this works, shall we? Okay. So, this is the enclosure that I've got. It actually comes in 6 parts. So there's a top part, 2 side parts, bottom part, front and back panels, which are normally just aluminium sheet, but I've actually laser cut some acrylic. So for the final version I probably won't use this acrylic, but this is just kind of a useful thing to test with, because I can laser cut it very easily, and because it's cheap, and also the fact that it's transparent is kind of handy when it comes to, you know, just seeing that everything is fitting inside okay. But eventually I'll probably get some aluminium plates made up like this one. This is actually from one of my EtherDream enclosures, one of these. So EtherDream is the laser controller. I put it inside an enclosure with a power supply in, and the bit that breaks apart the network and interlock signals. That's ILDA out, and that's the interlock output. This is a whole other project in itself, but honestly, such a good tip is these aluminium panels. If you were looking to get these like CNC milled and printed, they'd probably be £10 each. But JLC PCB, hashtag not sponsored, do aluminium circuit boards, single-sided. You can just send them a design with like no tracks in, and it comes back like this. I mean, look at it, it's amazing, and they're like $2 each or something, or $1 even, so cheap. An amazing fun little discovery is you can even have like shiny printing on it if you use solder mask and you get it tinned. Yeah, look at that. Sorry, that's my top tip for you. I think that's pretty if nothing else, that's all you need to know from this live stream. Okay, so let's have a quick look at this this back section. Okay, so here's the power supply. It's the same power supply that I designed for this, and yeah, this is kind of cool because normally these PowerCon sockets have got big sticky out spade connectors, so it's very difficult to get a narrow sort of design that doesn't take up loads of space because you've got the spade connectors and it goes on there. But I realised that if I just put slots in the PCB and then I could get rid of the extra plastic that's on the PowerCon socket, then yeah, you've got a really narrow power supply. This is the Vigatronics voltage regulator. Not cheap, you know, £10 each or something, but look how compact they are. And for this design I've even got the fuse protruding out, so you don't have to open it up to change the fuse. And then on this side is the external interlock in and out. So let's I guess we can put this together, can't we? Maybe I'll leave the lid off for now. Let's see how that works out. So the tricky part of this build is getting this to sit on there, because you've got to line up all the LEDs. So I tend to try and bend them out a little bit first. Because then you've got to try hook it over the Ethercon tabs and also get it into the LEDs at the same time. I'm sure there's probably a better way to do this. You know, maybe the LEDs could be smaller or something, or not go quite to the front. Anyway, there we are. Oh, and also a thing I forgot to do is here on these switches, these switch between gigabits and combined input on the front. And it's sort of hard to find switches that go all the way to the front. But I found these and they're close, but then I just 3D printed these little blocks that just sit on top of that, and eventually I should glue those on, I think. But for now, let's just friction fit it on. And that should slide on with a bit of persuasion. Oh, is it going? Doesn't want to go in. I think it's this one. There we are. Okay, good. And I think we're in. So before I lose that, let's put some bolts in. Oh, another really handy tip that I learnt from my friend Rob Stanley of Stanwax Laser is that you can put an M3 thread into these Ethercon sockets, so you don't need to mess around with the self-tapping screws, which I don't really like. So very easy to put a thread in. And also I think at the moment I've got two holes for every Ethercon, but I think eventually I might dispense with that. I think I can probably get away with 2 screws per pair of Ethercons. Okay, so now you can see these switches, and they're really pleasing because they just protrude a tiny bit, so you can't switch them by accident. They've got a real nice solid kind of movement. I don't know about you, but I hate weak feeling switches. So now I've found some that are good. Yeah, I'm very pleased with that. Okay, so this board here manages the interlock in, but it just duplicates it from the back to the front. So if this is in combined network and interlock mode, you just put the combined version in and then you've got like 7 combined outputs. But if you need gigabit, switch those two over. You've got gigabit in here and you can use the interlock input and output on the back. Shall I put the lid on? Maybe I will put the lid on. Yeah, let's do it. Eventually I'll probably spray these aluminium sheets. Oh, can I get the lid on? That's a good question. So yeah, these enclosures are from a local company. Oh, I didn't put the power in. From a local company to me, I think they're in Sussex somewhere, called Lincoln Bins, and they specialise in electronics enclosures. Their stuff tends to be quite expensive. Like any aluminium enclosures, you know, they can easily be like 30 quid each, 50 quid each, even more for like larger size ones. These ones that I put the Ether Dreams in, they're really cheap. They're less than £10 each. I did spray them black. That's why they've got that sort of scratchy effect on. But yeah, unfortunately the ones that come a bit bigger are a lot more expensive, which is a bit disappointing, but it's okay. And one of the things I didn't like about them was that the top section was quite easy to squeeze in, so that's why I 3D printed these plastic sort of surrounds, I call them bumpers, that go around the front, and that just helps keep everything together. So a few screws in the corners, I'll just put a couple in for now. I had, when I posted the last video, I had a really good question, and it was really diplomatically written. I really loved it. But it was basically like saying, why don't you just, this is an awful lot of work, why don't you just use separate cable for your interlock? Which is a really good point. I think I addressed it slightly in the video, but there are a few reasons why that's not always great. Primarily because, I mean, when you've got an installation with like 30 lasers, cabling is kind of your biggest issue and expense. You can easily spend thousands of pounds on cabling. But also I tend to use lots of different types of lasers, so they're not generally compatible with each other, so you can't always even daisy chain the stop signal between them. So that's the two main reasons. But yeah, it's a ridiculous amount of work for something that should be relatively simple. Anyway, let's power it on. So there you go, you see we've got the power light there. And so this is the interlock in and out, and I can bypass it by turning that on to get a white light to show that the lasers are active. On the other side, yeah, you see it's on the front too. So these are, yeah, like I said, either gigabit or combined inputs. If I plug in a network cable, hopefully you'll see the data light come on. Yeah, so there you go, you can just about make that out. It's not super bright, but then the thing I've learned is that for these kind of pieces of equipment, you don't want them super bright. Like one of my early designs had like full brightness LEDs on, and when you're in a dark stage setting, I mean, it just lights up the entire backstage like a Christmas tree. Now I don't have one of my finished stop buttons here. I've got one that's in pieces, but hopefully I can show you its kind of operation. So what we have is this button here, which is the stop button switch. So it's open. It's connected when it's unpressed. When you push it, it disconnects. So that's the stop button, gets pushed onto that and it stops everything. But if we plug into the combined input, you can see here we've got two status lights. The green one shows us that there is power, but the lasers aren't active until you push this restart button. When you do that, the other light comes on. Did you see that? Yeah. So when you push that, it comes on, and along with that, that white light comes on the front, which, let's just turn up so you can see it. And when that light is on, then the interlock output for all of these 7 are also enabled. So your lasers are on. Yeah, so, I see there's a question. What was the old standard in interlock, having 1 button for each laser, but that's a lot of buttons, and wired? I've searched around and haven't seen a splitter. So I think what you're talking about is the fact that there isn't really any standard for interlock at all. And I've seen some horrific, I switch cameras while I'm talking to you. I've seen some horrific installations where every laser has had a separate stop button. So if there was an emergency, you wouldn't necessarily know. You've got this field of stop buttons in front of you. You're hitting like whack-a-mole to try and stop all the lasers. So yeah, it's ridiculous. There should be a standard for interlock signal. It's absolutely ridiculous. If you're lucky enough to use all the same laser, like if you're using a fairly reputable brand, then they should have the reset system built in, especially if they say that they're conforming to BS 60825. Then that's one of the parts of BS 60825. But yeah, if you're using all the same kind of laser, then you can get a stop button into the first one, daisy chain into all the others. But yeah, there's no real easy win if you're using different lasers. What's the next question? Do you use many Ethercon cables or usually standard Ethernet? These days I tend to use Ethercon. We've just invested a ton of money in Ethercon cables. If I'm doing a little small gig somewhere with some smaller lasers, I might use some RJ45s, standard Cat5s. But generally we're entirely Ethercon, especially if we're in an outdoor gig. They're just a little bit more waterproof. If there's like a really long cable run and we don't have the Ethercon for it, we sometimes just use a Cat5 or whatever. Anyway, I think that's probably all I want to talk about. Yeah, so if there are no more questions, I'll probably round up this live stream. But yeah, in the middle of crazy busy period, I just thought it'd be good to kind of review what I've been doing. Oh, there may be some changes coming to this design, which, the things that I'm thinking about that I'm not sure about. Things I want to change. I feel like these Ethercons are just a little bit high in the box. It'd be nice if they can move down a bit. Now I've used a switch that's a bit narrow, there might be some more room to come down. Even a couple of mils will help. The other thing I'd quite like is at the moment we've just got this one light to show that the interlock is enabled. And in my older designs I'd have a light come on for every single output. And although that's not really needed as such, I personally feel that it's just a bit more intuitive and reassuring to see that there's every single one of these lights lit, and it just shows, especially for a prototype piece of equipment, you at least know that power is going to each part of this board. But I think this is I'm very pleased in a lot of ways. So with how compact this is, usually you'd put these into a big enormous 1U rack case, and there'd be, lots of wires, so, I suppose I could do a version of this that has RJ45 sockets on the back, and so then you could build it into a big rack and have all your little Cat5 patch cables behind going in. So I might do something like that, but certainly for this design, for a nice self-contained unit, I'm really pleased with it. It might be good to add another stop button input. and I have this board here, which is an independent stop button. So I could put the two stop signals in series. This has a bypass as well, so when you're not using it, you can just bypass it. So I'll probably do that. Yeah, but on the whole, I think it's pretty good. I'm wondering if it's confusing, this thing here. So at the moment on the front, these are two combined. If I go to gigabit, then I need to use the two on the back as interlock. Is that confusing? I guess the danger is you could plug a stop button into the front and into the back, and then they both need to be pressed in order to extinguish the lasers, which I think isn't ideal, but I'm not sure how I'd get around that unless... I mean, the only way to get around that is if this input was completely separate and independent from this input, in which case I'd also need to put a bypass on the front for when it was in gigabit mode. I mean, even just finding a switch that could switch 4 connections, you know, which the 4 spare ones from the combined, from the interlock signal to the network signal. Got some more comments, let's have a look. Very pricey. Ryan J, very pricey. What's very pricey? Oh, Ethicon. I think they're talking about Ethicon. Yeah, I mean, Ethicons are pricey, but then all my lasers are pricey. You know, when you spend, you know, tens of thousands of pounds on laser hardware, you shouldn't think anything of spending £50 on a network cable after that, right? And that was something for the longest time that I sort of fought against. It seemed just too weird. You know, spending money on, just get the focus, spending money on cables. But yeah, I mean, cabling is always going to be your hardest thing to sort of troubleshoot. So the more you spend on cables, the less time you're going to spend messing around trying to fix them. What are the Ethernet ports on the back for? So I did cover that, I think, already. But the Ethernet ports on the back are for when, so this is a combined input and output, which means it's the interlock signal and the network signal, but sometimes you might need gigabit. So if I switch over to gigabit, it means that it uses all 8 wires on the network cable, but that might be desirable sometimes because you know, you might need the bandwidth, but then of course you've no longer got the combined signal in, but you could still use the combined signals out. It just means that you've then got to use a separate interlock signal in the back. Yeah? It's so... I spend so much time on this stuff, and it's so dumb because it's conceptually very simple, but it's fiddly, and it's really confusing to try and explain. Can you make it so it's possible to have 2 inputs, so one button at front of house and one... Yeah, I did just mention that. I did just talk about that. And the way I would do that is to use this separate interlock board, and I could put it on the back, and I could put it in series with this input. So yeah, then I could do that, and I think I will do that because I think that's quite important. Can you? Is the front going to be a PCB as well? I mean, the front is a PCB. Oh, the front, you mean the plate? Yes. Eventually I probably will use this trick of doing metal PCBs as a front and back plate. Ever thought about going 5 GHz and point to point? Yeah, we often go point to point for certain ones of our sites, but there's no kind of stop button protocol that goes over a network as IP. Like this isn't going over, this signal isn't going over the network as data. This signal is literally just hijacking the wires in the Cat5 cable. So if you were to put it over 5 GHz or a P2P, you would need to make a stop button network protocol that was safe, that worked over a network, and that if the network went down, the stop button would trigger at the other end. I have actually designed a prototype of that. Maybe I'll talk about that in another episode. In fact, I did it a couple of years ago and I've used it a few times. but very much as a test, and I always have humans at the other end too to keep an eye at that with a stop button too. But it's something that I would like to do more in future. Certainly in some of our shows, the lasers are going to be spread like 1,000 meters apart, so I'm going to need peer-to-peer networking just to keep them all synced together. But yeah, like I said, while we're testing this IP system, I need to have physical stop buttons and crew at all those locations as well. I think that's all the questions. So I think I'm gonna wrap it up unless there's any last minute questions. How do you click the interlock in? How often do you click the interlock in a show? It almost never happens. The reason it's designed, and the reason you just don't pull the power out of a laser, is that it's much safer to do it in a way that the laser's designed to do it. Because if you just pull the power out of a laser, the mirrors will go to an extreme angle, and the laser could still be powered for a certain amount of time. So it's dangerous to just pull the power out on a laser. So that's why we use the built-in interlock systems in lasers. You probably know that already. The only time so the interlock signal is if something goes wrong with the software and the laser starts flying around all over the place, then you'd hit the button. That's never happened to me, I don't think. There was a point, actually this is a good PSA, in that if you're using EtherDream 3s, then update the firmware as soon as you get them, because there's a bug in the firmware that comes with it that sometimes rotates the output, putting it in a very weird, unpredictable position. So update your firmware on an EtherDream 3 if you get one. Other than that, the only time I've ever pressed the button is if someone starts wandering into the laser, there's a crew member or it looks like someone's going to enter an exposure area. That's the time when I push the button. And so usually at the end of the night, just to turn all the lasers off, you'll hit it. And also you have to test it as well before you run the show. So yeah, I just give you a couple minutes to think of any more questions. I wonder if there's anything else about this that I've missed. So yeah, interestingly, like this was my initial sort of relay board design. Not relay board, well it is a relay board. This is the interlock system with the reset that I designed, and you'll see that it's got a horizontal PCB, and I thought that was kind of easier to sort of make sure that the switch lines up with it. But these switches are a bit flimsy. The first ones I used were even more flimsy, but these are still a little flimsy. I'm much happier with this new design there, but I don't know if you can see that actually, but the board inside is vertical now, and I found a really long button that just about reaches the outside. So yeah, I started doing more vertical PCBs, and these are obviously vertical too, so that's quite a space-saving design, but you've just got to make sure that all of these buttons and LEDs all line up with the front panel. But I'm liking that, I think that works. Ryan J, do I have any shows coming up? So I covered that briefly at the beginning of the live stream, but I've got a show on Saturday in Milton Keynes for their City of Codes and Light event. I'm not going to be there, but my crew will be there running a laser show a couple of times. It'll be at Milton Keynes Station. I'm helping my friend Flora at Light Night Leeds next week. I think Light Night next week is Thursday and Friday night. Worth going if you are anywhere near the north of England. It's a huge light festival. It's very impressive. What other shows do I have? I've got a few coming up. They got two inquiries for November. It looks like I'm going to be doing something in Coventry for their Christmas light switch on, and then an enormous project in Newcastle. We're doing their New Year's Eve laser display again, and that's a whole new show. Cool. Alright, well, it's nice to see you all chatting away in the comments. It's very cool. I hope you've enjoyed this live stream. I'm sure if you're watching this after the fact, then please add some questions in the comments. Yeah. Hope you enjoyed it. Thanks for joining us, and I'll see you on the next one. Now, stop streaming.